Hey, 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 darlings. Welcome back. How's everybody doing? It is, let's see. This is video lesson. Oh my gosh, what are we up to? Video lesson 12? Yes, video lesson 12, I think it is. Yeah, video lesson 12. I can't believe it. I can't believe that I've gotten this far. I still can't believe that we are not in school. So I got into the building on Thursday for the first time since March 12th. Mr. Scotto was allowing a few people in at a time, and I was able to get all my answer keys. Yes! So Sakaro feels like a liberated teacher right now. I'm not doing all this videoing and editing and uploading, which is literally takes hours. The YouTube part of it is the worst, no offense. And then on top of that, rewriting answer keys that I had in my classroom already done, which was driving me knuckin' futs, if you know what I'm saying. Doing work that's already done. How annoying is that? So I got my answer keys. I'm so excited. Look at all this beautiful work. Look at this. Look at this. Look at this work. Look at all of it. Look. Ah. Anyway, so I think my husband's equally excited too, because I'm not going to be spending as much time on all of this. Hopefully it'll limit the stress load a little bit here. So a little bit of an update, because I know you guys love when I tell you my stuff. It is Sunday here at the Sakaro crib. The kids are chilling with Jimmy, and they are watching Mr. Bean. This is their new thing, Mr. Bean. You guys probably don't even know what that is. You should definitely watch him. He's kind of really stupid and funny. He doesn't talk, and he just does like stupid comedy, for those of you who don't know. But yeah, so we're just chilling out. It's almost 3, and I'm doing my lessons setting up for tomorrow for you guys. We're going to spend, I would say, this week, we have to do trapezoidal sum, which we're going to do today, which is an extension of LRAM, RRAM, and MRAM. Yay! So if you didn't hate it enough, we're going back to it. We're going to do fundamental theorem of calculus the second half of this week. The FTC. To me, that's easy like Sunday morning. Usually that's how I end this unit, because I like to end it on a good note. And usually when I do it, kids are like, that's it? And I'm like, that's it. And they're like, oh my God, this is so easy. And I'm like, I know, you're welcome. So after all this madness, I'll end it really nice at the end of the week. So then the next week, which would be the week of, if it's April 26th today, right, Jim? April 26th? He's not even listening to me.
Huh?
April 26th, right?
What?
Today?
I don't know. The lockdown, I don't know anything that's going on anymore.
Oh, you suck. He's fired. So yeah, it'd be like the first full week of May. We're going to do a review and a graded assignment on all definite integrals. So it'll have LRAM, RRAM, MRAM. It'll have, which are the Riemann sums, the rectangular approximations. We'll have definite integrals, so add 1, put it over that number, all the definite integrals of sine, cos, tan, and secant. And then we will do trapezoidal rule and fundamental theorem. Like anything else and like everything else, the video on Monday, I will probably go over homeworks from fundamental theorem of calculus, and then assign you a review sheet that'll be due Wednesday. And then Wednesday, I'll go over Wednesday's video. We'll be going over the review sheet, and then you'll be assigned the quiz that'll be handed in Friday. Okay, so you basically have an overview of the next 2 weeks. We're doing trapezoidal rule. That homework will be due Wednesday. Then we're doing fundamental theorem of calculus. That homework will be due Friday. Hopefully you guys are getting into the routine of how I've kind of set up our remote learning, our digital learning here. And then the week after, we'll do a review and a quiz, okay? And then we move on to even more fun stuff. All right, so little update on Sakaro. I am 7 weeks, T-minus 7 weeks to baby. Holy crap-ola. We're kind of freaking out here. We were, as I left you guys, the last, March 12th, the last few days leading up to March 12th, we were talking about coronavirus. And I had said to you guys, like, oh, don't worry about senior trip and prom. And, at the time, your leading scientists and experts and doctors from all over the world were equating this to flu season. They're still kind of on the fence with that. So as the weather gets warmer, because it does respond to the sun, which I don't want to get into the comment that the president made a couple days ago. Here comes Olivia.
We're gonna do a circle of life, and we're gonna hold the baby up for the parade, like circle of life.
They have no idea what you're talking about right now.
Like the Lion King.
Like, yeah, but they have no idea what you're talking about right now. They don't even know.
You explain.
I'll explain. Get out of here. I'll explain what she's talking about in a second. So yeah, basically, they were equating to the whole coronavirus of being similar to the flu. And if you remember in the beginning, all the experts were saying what I said to you guys, be more concerned about the flu, and the more people die from the flu each year than this. As you know, that's all evolved and changed at this point. It is drastically different than the flu. It is way more contagious. It has completely different symptoms, and the science behind it is very interesting. And I hope your science teachers are talking about it a little bit with you guys, because it's an RNA strand virus, which is weird because it's similar to like a DNA chromosome, and basically it can change and mutate, and that's what it did to go from what they believe it started as a bat in China. In the wet markets, to somebody ate a bat and it mutated from being a bat virus in the species of bats and jumped the mutation strand, so the RNA mutated and became a human virus, human viral infection. And then it mutated a second time, and it did this all within a matter of days, which is blowing the science community's minds, because for mutations to occur, it usually takes much longer, but this happened in days. It mutated again to then transfer from a human to a human. It's still going on. As I'm sure you've heard, there are, Jimmy, was it lions that, no.
It was a tiger, but now it's house pets.
Yeah. It was tigers in the Bronx Zoo that tested positive for COVID. So it's mutated and jumped again, because you're talking it went from a bat species to a human and then mutated from a human to a human. Now it's mutated and went from human to, you said tiger, right? I'm so dumb I can't even keep track. And now last week they have 2 reported cases of house cats, house felines that are COVID positive from their owners. So my theory, completely my opinion, is that that's part of the problem with this, and that's what makes it so drastically different than the flu virus, is its RNA component and its ability to mutate so fast that they can't get a handle on it. So I hope you're all being safe and being well and trying not to go too crazy. I know we're going crazy here at the Sakara house, but we're trying to deal with it. I think the only thing that's not making us too crazy about this whole situation is we're very distracted by the baby coming. So with that being said, what was Olivia talking about? So really quick, and I know I'm droning on, I'm sorry. I went to the doctor last week and everything is good so far. I have my first sonogram in a really long time is scheduled the week that we'll do a review and a quiz. And it's going to be an interesting birth if things continue the way they're continuing. I deliver in Southside Hospital. My doctor runs the maternity floor there. She's part of the board of the hospital. There's no more maternity unit at the hospital. Apparently Southside Hospital, statistically speaking, was one of the hardest hit hospitals on Long Island, due to the fact that it has a huge Hispanic population in the community, and the Hispanic and African American populations have been very hard hit by COVID. They're trying to figure out that RNA component as well. So there is no more maternity floor. Southside has one of the leading maternity floors in the state. They have their own separate entrance. So here, Jimmy and I thought, this is great. Like, that hospital has its own entrance. We should be completely safe. Actually, it was so overrun, they took over the maternity floor. It's all COVID positive patients. I am a planned C-section, so as it stands, I will go in, have a C-section in the operating room where it's a sterile environment. Jimmy will so far be allowed to be in the operating room. We don't think he's allowed to hold the baby. I will be tested for COVID upon entering the hospital. My doctor blew my mind and told me over 85% of women coming in for labor and delivery are testing positive and they have no symptoms at all, which really blew my mind. They, as of right now, are not isolating the baby from the mother if she's positive. They're letting the baby stay with the mother. The thinking is, first and foremost, if the mother is nursing, then the baby's getting all the antibodies. And secondly, what's the point of taking the baby away from the mother when 24 to 48 hours later, you're sending the baby home with her? So that panicked me at first, because I'm like, oh my God, they're gonna take the baby from me and the baby's gonna be alone. So Jimmy will be scurried out. I don't even think he's going to be able to hold her. He's really upset about that. And then the baby and I are going to be transported via ambulance to an off-premise facility. It sounds like right now they're renting out spaces in doctor's offices that are closed. So currently, she said last Tuesday they had all her patients were sitting in a gastroenterologist office, and that's where they were doing their postpartum recovery. Jimmy will not be able to come see the baby. No visitors, no anything. So possibly the first time Jimmy will hold the baby will be 3 days after she's born, which really sucks. This is not a good thing. We're very upset about it. But Olivia is the most upset because she remembers Ophelia being born. She remembers coming to the hospital. We let her come in before any of the family did. She held the baby first. It was a big deal for her. She's very excited about the baby coming, so she was very upset by this. That and the fact that she's not going to see me for a few days. So we came up with this wonderful plan that I told her and Daddy and Ophelia are going to be setting up while I'm in the hospital for a very big party when we get back. And we're going to order balloons and do all kinds of craziness, and she's going to help Daddy decorate, and we're going to do, everybody's doing these birthday parades, which we have also taken part in on my family, myself, and I love them. I love a good parade. But we're going to do a welcome home parade and have everybody drive by because they can't come to the hospital and meet the baby. They're probably not going to be able to hold the baby. We'll have to see if that changes in the next 6.5 weeks. I said 7 weeks, but it's really 6.5. And Olivia is so excited. My mom is the one who suggested we should all dress up like Lion King, and Jimmy should hold the baby up like Simba in the scene The Circle of Life whenever he drives past. So that's what Olivia was referring to. So this is my dumb family, and this is how we're coping right now in the quarantine of coronavirus. But listen, hey, it would be my luck, guys. Come on. That some people say they had babies in blizzards. Some people say they've had a baby in a hurricane, and I'm having a goddamn baby in the middle of a global pandemic. So here you go. All right, so moving on. That's enough of me, but I know a lot of you have been texting me like, I miss your stories. So there you go. I gave you some. So now you can stop complaining. All right, so let's start out. Let's get back to calculus. Yeah, buddy. All right, do we see no shadows? Okay, just making sure. So this is notes.
You want to erase it? You want to erase that? Look, keep the eraser there, right?
For video lesson 12. I'm trying to keep track here because, like I said, I go back and forth and I look at it, and this is Calc Honors. Okay, so a couple of homework questions because some of you were texting me about homework stuff. So I'm going to start there. Your homework was, I believe, 27 and 31 on example 3. Yep, 27 and 31. And then 1 and 3 on example 5. Okay, so let's look at 27. 27, you went 0 to 2. And it was x times 2 plus x to the 5th, I believe I wrote it as. dx. And then while I'm here, I'm going to write 31. 31 was 0 to pi fourths. And it was secant squared t dt. And I just want to make sure that that's how we wrote it when I left off with you guys. Yeah, x to the 5th. Okay, great. All right, so let's see. First thing we do is if we can simplify. So I'm going to distribute x times 2x. I'm sorry, x times 2 is 2x. And x times x to the 5th is x to the, that's right, you add the exponents, x to the 6th. All right, now add 1, put it over that number. So add 1, put it over that number. Add 1, put it over that number. All right, I'm going to simplify this a little bit. The 2's cancel. Who do I plug in first, the 0 or the 2? That's right, you plug in the 2. So it's 2 squared is 4. And 2 to the 7th. Oh, I think 2 to the 5th is 32. 64. Is it 128? Yeah, buddy. This girl is on fire. All right, there's the 2's. And then 0 squared, 0. 0 to the 7th, 0. So it's just minus 0. All right, so we have, this would be 28 sevenths plus 128 sevenths, right? Okay, and 28 and 128 is 156 sevenths. Can that be reduced?
Hopefully.
Oh, that's it. So we're gonna leave it as 156/7. All right, my dear darlings. Okay. This one, secant squared. The minute you see a trig function, we're gonna get tricky with it. Na 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 na. Na 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 na. Getting tricky with it. I'm gonna write all my derivatives down. When in doubt, write it out. Derivative of tan is your mom squared. Derivative of secant is secant tan. So I write them all down because an antiderivative is working backwards. And a lot of times when you guys try to go backwards in your head, it confuses you. So now I'm looking at this side and looking for secant squared. There it is. So what's the antiderivative of secant squared? It's tangent. So tangent t, and we're going from 0 to pi fourths. What is pi fourths in degrees? What is 180 divided by 4? 45 degrees, very good. So this is the 30, 45, 60 chart. Okay, so if we do tan, start with the top plugging in, minus tan at 0. Okay, so 30, 45, 60 of tan is rad 3 over 3, 1, and rad 3. So which one's the 45? It's rad 3 over 3, 1, and rad 3. That's right, it's 1. Minus tan of 0. Okay, this is where you have to think of the unit circle. And tan is slope, y over x. Remember? Sine over cosine. Tan is sine over cosine. So 0 over 1 is just 0, which means the answer is 1. How are we doing so far with 27 and 31, guys? All right, let's look at some average values. So now we're looking at example 5. So this was example 3, exercise 3. So we'll look at exercise 5. And we have 1 and 3. Okay, so they wanted, here's your function.
That's a light check. The plane crashes, they have over.
And they're going from 0 to 4. All right, the average value. When you hear average value, it's 1 over b minus a. And you integrate from a to b of the function. Okay, so 1 over b minus a. Here's my a and there's my b. What up, b? So what's 4 minus 0? It's just 4. Then we're integrating from 0 to 4, and here's my function. Okay, so if we keep going, add 1, put it over that number. Add 1, put it over that number. But don't forget, the last step is to multiply by that 1/4 outside. 4 divided by 2 is 2. I'm sorry. 2x squared minus x cubed over 3. Okay, so we're going to plug in the 4 first. 4 squared, 16. 16 times 2 is 32. Right? And then 4 cubed is 64. Help a girl out. Oh.
That's very funny.
Yes. So this is 64 thirds. If I plug in 0, you just get 0. So 32 thirds, 32 if you convert to thirds is 96. So 1/4, and I'm going to have 96 thirds minus 64 thirds. Again, most of you would just put this in the calculator.
Libby, it's only fair. To be fair.
Don't complain to me, I'm teaching. I'm going to reduce before I multiply. 4 goes into itself once, it goes into 32 8 times. And there's your answer, 8 thirds. It's a lot of fractions, but once you guys get to this point, you could literally put that in your cell phone calculator. If you turn your cell phone to the side, and I can't show you guys that because I'm using my cell phone to record. Oh, Jimmy, let me see your cell phone for a second. So I keep saying this, and Jimmy's actually home, and I'm recording. If you go to your calculator on your phone, can I just show them something?
Yeah.
Okay, so if you go to your calculator and you turn it to the side, hold on. You see what it does? It gets fancy. All right, you have a lot more functions here. You have like cube roots. This could be like a fifth root if you want it to be. You could do things with fractions in here. So this is like your basic, more upper level calculator. Thank you, sweetie. All right, I said thank you, sweetie. He didn't even say anything. He doesn't like being sweetie, I don't think. All right, so anyway, now we're gonna look at, that was number 1, 8/3. All right, let's try number 3. So this is still exercise 5, but now it's number 3 because I heard a lot of you said you had trouble on the last one. So the function is G money, the cube root of x, and you had to find the average value from 1 to 8. So again, 1 over b minus a from 1 to 8 of the function. I should have just put from a to b if I'm writing it eternally. Sorry, guys. All right, so 1 over 8 minus 1. This is my a, this is my b. I'm going from 1 to 8 of this function. Now, a lot of you had trouble with this one because you forgot. The first step is simplify if you can. How the hell do I simplify a cube root? In derivative world, I need it as an exponent, not as a root. So this becomes 1 over 7. And instead of cube root of x, I'm going to write it as x to the 1/3 because then I can add 1 and put it over that number. I need it in exponential form. Don't forget about the 1 over 7 on the outside. Add 1. So if I do 1/3 plus 1 whole, it becomes x to the 4/3. Now remember, if I divide by 4/3, it's the same thing as multiplying by its reciprocal. So add 1, put it over that number. But when I put it over 4/3, I multiply by the reciprocal. And I'm going to go from 1 to 8. Okay? So don't forget about the 1/7 on the outside. So let's start with the 8. You always plug in 8 first. I'm going to do 3/4. Now, here we go. I cube root it. I make it smaller before I make it bigger. You could do either or. You could do 8 to the 4th and then do the cube root of that. But I think it's easier to make the number smaller and then raise it to a power. And then minus 3/4. And then we're going to do the cube root of 1 to the 4th power. So you ready? What's the cube root of 8? That's right, it's 2. And 2 to the 4th, I think, is 16, yes? Yes. So I have 1/7 outside, and then I'm going to do 3/4 times 16 minus, and then the cube root of 1 is just 1, and 1 to the 4th is just 1, so minus 3/4. Now, I'm going to reduce it first. 4 goes into itself once, and it goes into 16 4 times. And what's 4 times 3? 12. Minus 3/4. Okay. So now I'm going to make this into a fraction. I'm pushing this because I know a lot of you don't have a calculator. So it would be 48/4, right? 4 times 12 is 48 to make it a common denominator. And then minus 3/4. So I have 1/7 times 45/4. How are we doing so far? So I think this comes out to 45 over 28. Does that reduce? Nope, that's it. 45 over 28. Okay? All right, my dear darlings, how are we holding up with this? Are we okay? We're doing all right with it? Okay. All right, so hopefully that helped clarify some of the homework. Now let's move on and let's talk about trapezoidal sums. Yay. So we could put this worksheet, this notes packet that we've been working on and beating to death. I didn't look at examples 6 and 7. They just don't really apply to what we need, so I'm not going to waste time on it. If I had class time, I may have done it as extra stuff, but who needs extra right now in their life? Not me. All right, so we put that away. So the new handout, the new notes packet, check it out. So the new name of the game is trapezoidal sums, ladies and gentlemen. We're going to talk about how the definition of a definite integral as a limit of Riemann sums can be used to calculate a trapezoidal sum. So these rectangular approximations, your RAMs, the rectangular approximations, we've done LRAM, we've done RRAM, and we've done MRAMs. Now, just to kind of review it, LRAM starts with the letter L. So you add all the y's except for who? L. Except for the last guy. RRAM's the opposite. Add all the y's except for the first one. M stands for the midpoint. So you take your x and y's, you find the midpoint of each one, and you add them all up. So how does trapezoidal tune in? Okay. Hey, Ophelia.
I found a whole bunch of new channels.
Ophelia, no bite. Sorry. Jim, they're fighting with a marker in their hand.
Stop fighting.
Jim,
Yeah?
thank you. Here's a trapezoid. So just to give you a visual, and I'm not going to kill you with the visual because who has time for that? And I'm kind of over it. If you have something like a parabola,
Liv, let her watch her show for a little
and I want the area under the curve from this parabola to here, instead of drawing rectangles where you get an overestimate or an underestimate, imagine if you made them trapezoids.
Learn to share.
If I did a trapezoid top, then it's a little closer because of this diagonal side that I'm cutting off, okay? So it's a better approximation. I'm gonna refer to it as TRAM, but technically when you denote it, you would denote it with just a capital T. You wouldn't put RAM after it, okay? Because it's not really a rectangular approximation anymore because it's trapezoid. So it's not a RAM, okay? So let's warm up first. Let's look at the do now here. We're going from 0 to 2 of x to the 4th dx. Your homework on the textbook handout, which is this, page 295, 1, 3, 5, and 7. This is your homework for video lesson 12, okay? 1, 3, 5, and 7. 1, 3, and 5 are gonna be just like this do now. I'm gonna ask you to do a trapezoidal and then actually find it by integrating. So it's a little bit of what we've been doing all along. All right, so they want an LRAM, that's what this means, and an RRAM. And they want you to find it doing 4 equal subintervals. They want n equal to 4, okay? So I'm going from 0 to 2, and I want to cut it into 4 equal parts. How do you figure that out? 2 minus 0, okay? Top minus bottom. Mom's teaching.
But I want to tell you, Daddy's letting us watch one of our videos one at a time, and it's not fair. I mean, it's my
It sounds
turn.
like it's very fair if it's one at a time, but when I'm done teaching, I will deal with this. But
No,
listen
like-
to me right now. Dad is the boss. I am teaching. Turn around and walk away.
It's like.
Do you want to be
listen-
punished a second day in a row?
No, I want.
Then turn
I
around.
want to tell you something.
Turn around. You can tell me after I'm done teaching and walk away. Okay? So we're going to divide by the 4 equal parts. So it's 2/4, which reduces to a half. Okay? So I'm going to go by halves when I set up my table.
I'm sorry.
So you start with 0 and go by halves. So it's 0 and then a half. And then 1 and then 1.5 and then 2. Okay? How did I know to go by halves? Because I figured this out. From 0 to 2 is 2 apart, and you divide by the n, the 4 equal subparts. Means you go by halves. You guys can write as decimals. You can do 0.5, 1, 1.52. Now, remember, I gotta take these x's and plug it into the function to get the y values. So 0 to the 4th is 0, okay? 0.5 to the 4th is 0.0625. 1 to the 4th is 1. 1.5 to the 4th is 5.0625. And 2 to the 4th, like we already said, is 16. Okay? So the LRAM, remember to use your approximately equal to symbols. What is the base of each rectangle? How far apart is the bottom? How far apart is each coordinate, the x coordinate? It's a half. And then I add all of the y's except for the last guy. I swear we're not beating our children. She's whining because Jimmy's teasing her right now because she's being a crybaby. So if I put this all in the calculator, you get something like 3.0625. Okay, there's my LRAM. For my RRAM, the base is still the same, 1/2, and I add all of them except for the first one. So now I'm going to include the 16, but not include the 0.
I heard you say Daddy was better before.
So you end up getting 11 point, please don't say the word hate, 11.0625. Now, let's actually do the integral now that we know how to do this and compare where the answer actually falls. Okay? So it's somewhere between 3.0625 and 11.0625. By the way, for an MRAM, what would I do? I would take the midpoint of each of these, right? Which would make it quarters. Okay. Okay, so let's take a look. Let's actually evaluate it. Add 1, put it over that number from 0 to 2. So I have 2 to the 5th over 5 minus 0. 2 to the 5th is 32, right? Which means just 32/5. That's the actual answer. And let's see. There it is, 6.4. So you see how it's in between these two numbers. Okay? So what the hell is a trapezoidal? Trapezoidal is kind of interesting. Okay? So I'm going to flip this over on the back side and let's talk about a trapezoidal sum.
I'm reading about Mr. Crawford.
0 to 2, x to the 4th, dx. Now, there's two ways you could do a trapezoidal sum. We denote it with a capital T. So if we look at the formula part, here's the trapezoidal rule. You have, here's your first formula. There's two parts to it. I know you guys are like, what the hell is that? H over 2, oh my God. H is what we've been doing. The top number minus the bottom number and divide by the subintervals that they want, your ends. But then you got to divide it by 2. Okay? So basically, if I look at LRAM and RRAM, the H is this. But then my extra step for doing the trapezoidal is I would take this and divide by 2 to get the first part outside. We're going to do that in a second. Now, what are they doing with the Y's? WTF, like what is all this? It's the first Y and the last Y. And it's 2 times all the middle Y's. Okay? The first one plus 2 times the middle guy 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 plus 2 plus the last Y. So the first and the last Y stay the way they are, but then you do 2 times all the middle guys. Or, and most kids end up doing it this way, because you already know how to do this, it's the midpoint of LRAM and RRAM. So it's just LRAM plus RRAM divided by 2. I think this is the easier way to do it. I will show you both, and you can do whatever way you want. But basically, since I already know my LRAM and my RRAM, we could literally take these two answers to do the trapezoidal sum. 3.0625 plus 11.0625, and you divide by 2, because one of the definitions of a trapezoidal is LRAM plus RRAM, and you cut it in half. So if I put that in, we get 7.0625. And I'm sorry, it's an approximately equal. Okay? Now, let's look at the other weird formula. Okay? The other weird formula for trapezoidal says H over 2, the first y, 2 times all the middle y's, plus the last y. Now what's h? In this case, h is 2 minus 0 divided by, what did they say they wanted? 4 equal parts? My n is 4. But now you have to do, here's my h, 2/4, which is a half, divided by 2. So that means h over 2 is 1/2 divided by 2, which is the same thing as multiplying by the reciprocal. So that goes outside the parentheses, 1/4, which is basically taking a half and dividing it by 2 is 4ths. So the h over 2 is 1/4. Now I need my y's, okay? So the y's are what I have in the table already. So take a look at what I have. First y, last y, 2 times the middle guys. So it's the first guy plus 2 times these guys plus this. So 2 times 1, right? I messed up already. Sorry, guys. Trying to do it from memory. The first guy plus 2 times the middle guys. It's 5.0625. Plus the last guy. So here's my h over 2. The h is how we find what we've been doing for LRAM and RRAM. That's the base of the rectangle. And then you cut it in half. And then it's the first y and the last y and 2 times the middle guys. Now if I put that all in the calculator, check it out, yo. There it is, 7.0625. Now again, you get the same answer. One is LRAM plus RRAM divided by 2, and one is this crazy trapezoidal formula. So it's up to you, whatever you're more comfortable doing. I don't care. Most kids go in this direction because it's easier. All right, so I'm gonna do like 1 or 2 more here just to make sure you got it. So let's look at example 1. All right, take a look, read it to yourself. Okay. You want 4 equal parts from 1 to 2. When they say compare the value to NINT, they want you to find the actual integral. Don't worry about this notation. That's from the calculator, and we're not in school, and most of you don't have a graphing calculator, so they just want you to compare it to the exact value, just like we just did. So we could do LRAM plus RRAM divided by 2, or we can do the trapezoidal. I'm going to do both. All right, guys? So if I work on the LRAM and RRAM, let's get a table of values first. We're going from 1 to 2, so I need to find that H. So 2 minus 1, and they want 4 equal parts. 2 minus 1 divided by 4 is 1/4, 0.25. I don't know why I wrote 2 equal signs, but whatever. Okay? So I'm going to go by fourths. So I have 0.25. I'm sorry, not 0. 1. And then I'm going to have 0.25. 1.25. And then I'm going to have 1.5. And 1.75 and 2. Is everybody okay with that? Because I'm going by quarters. 1, 1 1/4, 1 1/2, 1 3/4, 2. There's my 4 equal parts. Now I take each of these and plug it into x squared. So 1 squared is 1. 1.25 squared is 1.5625. 1.5 squared is 2.25. 1.75 squared is 3.0625. And 2 squared is 4. Now I'm going to do both TRAMs. In order to do the first one, I have to do LRAM and RRAM first. LRAM, add all the Y's except for the last one. So I'm not going to include the 4. How far apart is each one? From $1.25 to $1 is what? 25 cents, right? Add all the Y's except for the last one. That's not my kids, that's the TV. Now if I put that in the calculator, you get 1.96875. Okay? And again, putting that in the calculator, it's just 0.25 times 1 plus... There it is, 1.96875. Now I'm going to do the RRAM. It's still 0.25 apart. I'm going to add all the Y's now, but not the first one. Add all the Y's except for the first one. Now if I put that in the calculator, I'm going to get 2.71875. Okay, and I'm just going to check that. What I do is I recall the top because I'm mad lazy. I do plus 4 at the end, and I delete the first one. The joy of having the graphing calculator. There it is, 2.71875. So the trapezoidal says LRAM plus RRAM divided by 2.
Liv, it's your turn.
So you get 2.34375. So there's your trapezoidal. Now, if you do the crazy formula, the h over 2 part, I'm going to do that work up here. Your h is this part that we already did. 2 minus 1 divided by the n, 4 equal parts, is a fourth. Now the h over 2 means I'm doing 1/4 and cutting it in half, which is the same thing as 1/4 times the reciprocal, which is 1/16. So the other way you can do it, which most kids don't do it this way, most do it this way, the LRAM plus RRAM divided by 2, is 1/16, and then it's the first y and the last y and 2 times the middle guys.
Can you hear me? I hit the wrong, hold on a second.
So I'll say it again. First y and the last y and 2 times the guys in the middle.
Yes.
My husband is doing a Zoom phone call with his friend because they're stupid. Is that Mike Smedley or your dad?
Mike Smedley.
Oh, okay. Hi, Mike.
I screwed something up on Zoom.
We should get that same answer. Huh. What did I do wrong? I did something wrong. 1 plus. Let's see.
How we doing? How about now? All right, there we go.
2 times 1.56.
No, I was hitting, it was asking me to
2
do something
times
with stupid background. I was hitting
2.25
deny
plus
or
2
something, and I
times
actually denied the microphone accident.
3.0625 plus 4. There's something wrong here.
Huh. I logged out of my own phone.
Oh,
What's new?
because I'm dumb. 4 times 2 is 8, not 16, guys. My h over 2 is 8. Please make that correction. I am so sorry. I knew I was doing something wrong because she should get the same answer and I wasn't getting it. So it's 1/8 times this, not 1/16. You guys probably saw me write this and went, it's 16. It's 16. Isn't 4 times 2 16? You're right. I'm wrong, as usual. So I can go back here and fix it real quick. I'm so sorry, guys. 4 times 2 is 8, not 16.
So, how's everything going?
And there it is, 2.34375. So you see, you get the same answer. I don't care which way you do it. Now, to get the exact value part, I'm going to squeeze in over here. Okay, I'm going to add 1, put it over that number from 1 to 2. Okay, plug in the 2 first. 2 cubed is 8/3 minus 1 cubed is 1/3, which gives me 7/3, and hopefully that's the same answer. It's pretty damn close. 2.3333 is 2.34375. You see that? It's basically approximately 2.3. So I just want you to see how close it is. So you see how close these answers are because it's an approximation. Much closer than your LRAM and RRAM. Your LRAM was 1.96. That's the actual answer, 2.3. The RRAM is 2.7, which is over. That's the actual answer. The TRAM, look how close it is. So you see how it's a much better approximation as your trapezoidal. Okay? All right, let's do, what time are we at here? Yeah, we're over our time limit. This example 2 is like number 7 in your homework. So basically, instead of a function, I'm giving you X's and Y's. My biggest suggestion is when they give you a table of values and not a function, stay away from this formula. I would do LRAM plus RRAM divided by 2. All right, my dear darlings. Again, I'm sorry about this mistake here. Make sure that's 8, not 16. All right, and you know what? We'll go over this one and do some of the homework problems in the next video. All right, my darlings. I hope you're all doing well. Take care. Brush your goddamn hair, and I'll see you later.